All right, we are going to get into compound naming, and before I do that, I like to talk about why compounds happen, which we don't cover until later, so I just wanted you to have some idea about it. All right, remember that the periodic table, you have your metals, which are the blue ones, you have your non-metals, which are the green ones, you have your metalloids. So when the metal and the non-metal come together, we talked about this, that's an ionic compound. There's charges involved. We'll talk about that. When two nonmetals are involved, then there's more of a sharing of electrons. There's not this hostile takeover, and that is covalent bonding. So, basics that you need to know, we'll always put the subscript number after the element, which there are multiple of. So, there are two hydrogens in water. So, that's why the 2 comes after the H. The oxygen, if there wasn't at least one, we wouldn't have written an oxygen. So it's always understood that there's one of anything. If there's more than one, we would put a number there. So for calcium chloride, that 2 is now talking about the chlorine. So there's 2 chlorines and 1 calcium. 1 understood because you wouldn't write the element if there wasn't at least one of them. All right. So again, remember every capital letter starts a new element. So this has only 2 elements because there's only 2 capital letters, a capital C with a small a and a capital C with a small l. This also has 2 elements, a capital H and a capital L. All right, so let's go over these. If you had this here, zinc and sulfur. So zinc is here and sulfur is there. We can agree that one's blue and one's green, so that's going to be ionic. Nickel chloride. Nickel is here, number 20, well, you don't care, but 28. Chlorine is over here, number 17. So again, that's going to be ionic. CHCl. So here's the H. Remember, that's a nonmetal. C is here. That's a nonmetal. And Cl is there. So that's all covalent. H2O. H is a nonmetal. O is a nonmetal. So that's covalent. Lithium, oxygen. Lithium's here. Oxygen's there. So that's ionic. KNO3. K is here. That's a metal. N and O, capital. So N and O are nonmetals, so that one's ionic. So there it is. All right, so why do these things happen? A chemical bond is an attraction that holds the two atoms together, and it takes energy to break them apart. So certain atoms like to come together in certain ratios, and it'll take energy to break those apart. They bond with each other because they want to be stable like the noble gases. They want to have full and stable electron orientation, and they can achieve this by, as you saw, losing electrons or gaining electrons, or they can share electrons, which is what we already talked about at the beginning of this conversation. The why. So here are the noble gases. The noble gases have 8 valence electrons. It goes 1, 2, skip a few, then 3, 4, 5, 6, 7, 8. So these have 8 valence electrons. Everything is trying to get to 8 valence electrons. These here in this D block we'll talk about later as to what happens there. But these are like the Kardashians of the periodic table. Everyone wants to be like them, and there's a bunch of them. There's Chloe and Kim, and uh, I don't know any more than that. So anyway, um, so what happens? Here's potassium. Potassium has 19 electrons. There's only 1 electron in that outermost shell. By losing that 1 electron, now it thinks it's a noble gas because it has 8 valence electrons. So the potassium always has a +1 charge when it wants to do ionic bonding because it'll lose that 1 electron and have a +1 charge, 18 electrons with 19 protons. For magnesium, it has 12 protons, 12 electrons, but if it loses these 2, now it thinks it looks like neon, so it's dressing like neon Kardashian. If another element comes up to it, it's going to see those 10 electrons. It's going to think it's neon, but it'll have a +2 charge because now it has 2 more protons and electrons. So that's what's happening with the metals. With the nonmetals, here's fluorine, 9 protons, 9 electrons. Look, it's just 1 away. If it just had 1 more electron, it could be like neon, and that's what happens. It'll gain 1 electron, but in the process, because it has 9 protons, it becomes F minus 1. Oxygen has 8 electrons, 8 protons. It'll pick up 2 so that it looks like neon, which is a noble gas, and now it becomes O minus 2. So that is why when we're doing this, everything in group 1 will be a +1 charge because they're all 1 above the noble gas and they'll all want to lose 1 electron. All of these will be +2. All of these will be -1 because they'll add 1 electron. to be like the noble gas that's closest to them. All these will add 2 electrons to be like the noble gas. All these will add 3. Silver, zinc, and aluminum, 1, 2, and 3, they are always going to be sort of those charges, and we'll get into that more later. So let's get into it. All right, so sodium. Sodium's right here, number 11. It wants to be like which noble gas? The closest number to sodium, number 11, is neon, number 10. And by losing 1 electron, it's going to become like neon. So even though it has 11 protons, it's going to lose 1 electron to have a plus charge, so it'll be a plus 1 charge. It'll have 10 electrons, and it's trying to copy neon. Bromine is here, number 35. It has 35 protons. It wants to pick up 1 electron to be like krypton, so the noble gas is trying to be like its krypton. Its charge will always be -1 because it'll have 36 electrons, just like krypton. Calcium, number 20. It's easier for it to go backwards 2 to be like argon, which is number 18, so it'll have 18 electrons to look like argon, but with 20 protons, that'll give it a +2 charge. And then aluminum over here is +3 because it has 13 protons. It's easier for it to lose 3 of those electrons to be like neon and have a +3 charge. So that's how this gets all filled out. All right, so the nonmetals share because they're both kind of close to being a noble gas. Hydrogen wants to look like helium. It needs 2 electrons for that to happen. So it will share 1 of its electrons and share 1 of fluorine's electrons to give it a total of 2. So now it looks and feels like helium. Fluorine needs 1 more. Hydrogen won't just let go of it, so fluorine will share that electron. It'll share 1 with hydrogen, and 1 of hydrogens will share with fluorine. So now fluorine thinks it has 10 electrons like neon. There are certain elements that just form what we call diatomic molecules, molecules that are just bound together when they're formed on the sun or whatever we want to talk about. So nitrogen will always form a triple bond with another nitrogen. Hydrogen will always form a single bond with another hydrogen. And if you think about this, this is because they're all achieving their noble gas configuration. Fluorine is just 1 away, so it only shares 1 electron with each fluorine. We'll get into this some more, but these are diatomic molecules. They make a number 7 on the periodic table, starting with number 7. The problem is you have to remember hydrogen is 1 because it's not really in that little configuration. Another way to remember it is this name Brinkelhoff. It's a nonsense name, but if you take all the elements that make up diatomic molecules, that's what it would spell. All right. So in the end of the day, carbon, because it has 4 valence electrons and needs 4 more to have an octet, will always make 4 bonds when it's doing a covalent bond. Nitrogen has 5 valence electrons. It needs 3 more to have an octet, or 8. So it will always make 3 bonds. Oxygen has 6 valence electrons. It needs 2 more to have a total of 8. So it'll always make 2 bonds. And halogens, chlorine, fluorine, bromine, those types of things, they all have 7 valence electrons. They need 1 more to have 8. So they will typically make 1 bond. And then hydrogen will always make 1 bond because it's trying to be like helium. All right, if you ever see this, people struggle with this all the time. It could mean it's chlorine, or it could mean it's carbon and iodine. Assume it's chlorine. It's very rare that we have a reason to write copper and iodine together. So if you see this and you're like, I don't know what that is it carbon and iodine or chlorine? Go with chlorine. And I think